Well, hello, my name is Dave. This video is for the final project of automation and robotics class. By all means, this is not a tutorial video, nor should it be referred for academic purposes. So subjects in this video might not be 100% accurate. So I am from Team 24, and we were tasked to program robot moves using ABB Robot Studio software for the project. So before we start, we must make sure that the controller is connected. And for this project, we are using Flex Pendant. And this is not connected to the robot yet, but make sure that the motor on this Flex Pendant is on. So here is what it looks like after we're done programming the code. So each move has 4 parameters to be changed accordingly. In this project, the fourth parameter is not changed at all. As you can see, all of these codes, all of these moves have tool 0. That's the fourth parameter. So the first one is movement type. The second one is speed. The third one is the accuracy of the positioning of the robot. So to begin with the movement type, there are many movement types, but the most common are J and L. So J can move the joints, the robot joints in curved path. It can also move it linearly, but it can reach a point not necessarily in linear fashion. But L is usually for linear movement only. As for the speed, the higher the V goes, the faster it will be. And then accuracy, the highest of the accuracy setting would be fine, and and then followed by Z0, Z1, the lower numbers, all the way to Z whatever there is. And then it would be less and less accurate going higher, going with the bigger number. So now, before assigning a move, a point needs to be defined. So we already did that earlier with by jogging the robot manually with this flex pendant interface. So, oh yeah, also if we take a look at these, the arrow here, this one indicates the movement of the robot that is trying to make, while the robot icon to its left is basically saying that the robot has reached that defined point. So, uh, yeah, let's just begin. Hit play. So, before starting, no matter where the robot was, it will return to the starting position. If it's impossible for the robot to return to the starting position, it will usually be resulting in an error message and stopping the code altogether. So let's hit start. As you can see, the robot is trying to move to the starting position. And then it goes, yeah, the starting position uses a relatively fast speed, not so much accuracy, because we're just trying to get to the point. And I mean, we can also start from position absolute 0 position for the robot. There is a setting on, I think it's on home, in home. But yeah, so we're already trying to make the move for the second position. So for these second and third positions, basically the position of the hand will be bending down, like trying to approach a part on an assembly line. And it will move mainly with axis 1, 2, 3, 1 through 3. So this is axis 1 of these. axis 1 are axis 1 through 3 are these joints right here, basically, right? And yeah, and we try to make it move accurately because we think that the robot needs to handle the part on the line with careful and much detailed movement. So it is set with quite slow speed and with the highest accuracy possible, right? So let's take a look. Oh, it's missing. toward the third, slowly and accurately. And then this one, the fourth movement, we try to utilize axes 4 through 6. So axes 4 through 6 are these axes. And this one we particularly, I think we're moving axis number 6 because, oh no, axis, or one of these axes. We're trying to move the gripper part of the robot, right? Hit play again. As you can see, it bends forward. And then this is the fifth movement. The fifth movement, we try to move the robot near to the starting position just to move it back, and it is done with a pretty fast speed and also less accuracy. Right? C10. Then we code the robot to do a 180 turn, but it appears weird later because during the programming we tried to use circular movements, move C on some parts, but it returned an error, so we had to delete some of the lines, but still the system will recognize and continue proceeding the next points, which are closer to the deleted position somewhere around here. Right? I'm gonna hit play again. Yeah, we're doing it with relatively faster speed. And then we try to make the robot swings toward the screen with a move J. Then uh, let me hit pause. So then we move the fifth axis and then the fourth axis. So it appears that if the robot is applying an operation on a different line, and the gripper would be facing diagonal to the part, so it would appear like this. Yeah, we are moving it. We're bending this axis. Up, there it is. So so this movement, if there's a tool attached on the gripper, this movement is a linear movement, which is done slowly with also a pretty high, well, the highest accuracy. And it could be used for operations such as cutting or marking and engraving on the part on that particular part on that line. So we want it to be accurate and also slow moving, right? To not miss any details or just to be careful. Mm. And it's done slowly. This is a linear move because there's only one axis that's moving. And here is, I'm trying to, well, we're trying to move the robot to another defined point, but we tried, instead of moving it with move J, we tried it with move L. And in this case, it moved just fine and there's no error message. There's two more L moves, right? After the previous movement. Well, yeah, the previous movement where we tried to drag the gripper to the left, right? And yeah, so it moves fine. Two of the L moves, they're trying to direct the robot to the defined points. It's just, it works fine. Then we try to use move J to bring the robot back up closer to the starting point with move J with a pretty fast movement. But soon after it completed it after it reached the defined point that we jog manually here, it will return to the original the starting point and also adjust its speed and accuracy of positioning. So it will come back up. It will come back up. It will rotate the robot fully. It will rotate these axes as well, right? Because previously yeah, we have not turned this back, but it will turn itself back because in the original position, none of these axes are moved, and mainly only these axes that were moved. So yeah, that is all. It's a complete cycle now. Robot is trying to do another cycle, and it moves just yeah, it moves back from the start. All right, that's about it. Thank you for listening. Thank you for watching.